Okay, these are the answers to the 4.1 quick check. I found a little picture here, and this is showing calcium fluoride. And one of the things about these ionic crystals is that what we have positive ions and we got negative ions. And so what happens with those is that they put themselves together in an alternating pattern we call a crystal lattice. And that's because, the positives and negatives want to be surrounded by the opposite charge. And if you look really, really closely up at like a salt crystal, you'll see this kind of a cubic pattern, just even on the macroscopic level. So it's kind of interesting. Okay, let's look at these questions. So we're going to form some ionic compounds. If we have Mg2 plus and I minus, what we're going to have, we're going to have two I minuses to balance the 2 plus. So the compound would be Mg I2, that's a G. Okay, and the name of that, because this is magnesium and this is iodide, the name is magnesium iodide. Now notice that the name has nothing to do with, how many iodides there are. Okay, this guy here is copper 1 plus, so that's cuprous, and here's sulfate. Okay, I'm going to need two of these coppers, okay, to go with my sulfate, so it's going to be Cu2. SO4. Okay, notice also that when we write the compound, we don't put any charges. Once they're balanced, we don't write the charges. And this would be cuprous sulfate. And we also might call that copper 1 sulfate. Okay, next example, we have aluminum and we have oxide. Okay, here we have 3 plus and here we have 2 minus. So we're going to need to have 3 of these O2 minuses. That'll give us -6. We're going to need 2 of these Al3 pluses that give us +6. So the compound be Al2O3. Okay, no parentheses. And the name would be aluminum oxide. And here's Sn2 plus, which we know is called the stannous ion. Here's NO3 1 So we're going to need to have 2 of these NO3 1 minuses to balance the 2 plus. So the formula will be Sn NO3 taken twice, we need parentheses, and the name of this would be stannous nitrate, or we might call that tin Roman numeral 2 nitrate. Okay, for the second set of questions, okay, now we have to kind of work backwards. So we look at this calcium. So we know that calcium is Ca2 plus because we memorize our ions. We know that phosphate is PO4 3 minus. And we can see 2 plus and 3 minus. We're going to have 3 of these and have to have 2 of these to make it balance. So the compound be Ca3 PO4 taken twice. We need parentheses on the phosphate. Okay, ammonium we know is NH4 with a plus charge. Carbonate is CO3 with a 2 minus charge because we memorize. So we're going to need to have 2 of these ammoniums to make it work. So we say NH4 taken twice, CO3. We need parentheses on the ammonium because we don't need them on the carbonate because we only need 1. Ferrous, we have to memorize ferrous is Fe2 plus. Chloride is Cl minus. So we're going to need 2 chlorides with our ferrous, so FeCl2, no parentheses. Okay, lead we learned is Pb2 plus, chlorate ClO3 1 minus. So we're going to need 2 of these ClO3 1 minuses in order to balance our Pb2 plus. So the formula will be PbClO3 taken twice. Again, parentheses on the chlorate. For this one here, we have copper fluoride, so we have to say, okay, that's going to be Cu. One of the things that Mr. Koo was mentioning, that sometimes it's better to start with a negative ion, because you can look at this and say, well, there's not 2 choices for negative ions. Sometimes for like copper, it could be copper 1 plus or copper 2 plus. And so since there are 2 negative fluorides on here, then this copper, to balance it, must be the copper 2 plus ion. So that means this is cupric fluoride. So if you start with a negative ion first, sometimes that's helpful. Okay, this guy here, so this negative ion is C2H3O2 minus, because we recognize the acetate ion, and we have 2 of those. So here we have zinc, and we know that zinc is 2 plus. And that makes sense because I have 2 of these negatives to balance my 2 positive. and the name would be zinc acetate. Okay, here we have silver, and we know that silver is Ag+, and there's two of them. And we have dichromate, Cr2O7 2-, and so that makes sense because the two Ag pluses would balance the 2-. So the compound here would be silver dichromate. And the last one here, we have SnS2. So we know the S is 2- for sure, and there's two of them. So that means this Sn must be the 4+ version of the Sn to balance out. So that means that this must be stannic sulfide. Okay, you can see on all of these, it's very, very, very important that you have your ions memorized. You need those. You need to be able to look at this and to know what those ions really represent. Okay, last problems here have to do with covalent compounds. So here we want to name these, and the name has to reflect what the compound is. So here I have 2 N's and 4 O's, so it's going to be dinitrogen. And it's tetroxide. You can say tetraoxide or tetroxide. So that tells us the formula. The next one here is going to be phosphorus. Remember, the first part of it is just the name of the element, phosphorus, and there's only one of them. And we have 5 chloride, so that's pentachloride. Third one, we can see we have sulfur. And we have 3 oxygens, so that's trioxide. Now the last one, sulfur hexachloride, so we have a sulfur, just one sulfur, and chloride with 6 for the hexa, so SCl6. Oxygen dibromide, here's an oxygen. Dibromide means 2 Brs. Notice these all end in "ide." And the last one, iodine, heptachloride, hepta means 7, so Cl7, ICl7. And notice we're not saying iodide because it's not ionic compound, it's iodine, the neutral element, each of those. And that's how we do Quick Check 4.1.